Hello everyone, welcome back to the third and what should be the final part of my review of the SMO Senior mock paper which I've written for 2024. The last section is going to be a bit weird. It is going to probably be the least familiar looking, and so for many of these questions it is arguable that you are not going to be able to figure them out within a short time if you have not seen the idea before. But hey, now you are going to get to see the idea, so if we are all fortunate enough that something similar to this appears in the SMO, then you are going to be pretty happy, and I will also be pretty happy. So let's jump in to where we stopped. We did up to question 17 in the previous part, and if you have not seen that video yet, please do watch that first if there are any questions from there which you are curious about. If you have not tried the paper entirely, then what are you doing? Why are you watching the third part of a review if you have not tried the paper? Just try it first. Let's come in and start on question 18. Fn is defined to be the number of zeros at the end of n factorial. So we know that we have seen counting zeros questions before in a lot of Olympiad problems. But this is a bit different. It's asking how many positive integers m less than or equals to 2024 are not in the range of Fn. Now, what this means is quite simple, right? If let's say, for example, I have got f of 5. F of 5 is, well, 5 factorial is 120. So it's 1. So 1 is in the range of Fn. And let's say that you put f of 10, now f of 10 is 2, 2 is then also in the range of Fn, and so on. But I'm claiming that some things are not in the range of Fn. And so if they are not in the range of Fn, then how am I going to find those numbers? And how do I know that they're not in the range? And how do I know how many of them are not in the range? Well, here's the idea. The idea is that number of zeros is the number of tens. The number of tens depends on 2's and 5's, and we have more 2's than 5's in a factorial. So each time when you hit a multiple of 5, you are going to increase the number of zeros. And because the 5's are the quote-unquote limiting factor, limiting reagent, for those of you who have just did your chemistry test, you are going to have got a jump only at the multiples of 5. So it's going to be f of 1 to 4 are equal to 0. Then f of 5 up to f of 9 will be equal to 1. F of 10 up to f of 14. So they do not give you any extra zeros each time when you go through the non-multiples of 5. But some of them would jump. So for example, at f of 20, it's still 4, but at f of 25, f of 25 is a multiple of 5 squared. It is 5 squared. So it will add in 2 5's and therefore add in 2 zeros, and that will be a jump. We are trying to deal with these jumps. But if I were to count how many times it jumps, that's not going to be very good. Because if it jumps, sometimes it jumps by 1, sometimes it may jump by 2, sometimes it may jump by 3, and it is very confusing. Moreover, even if I capture how many times it jumps, I also need to know when I have to stop looking. And so I want to know, where am I going to find 2024 or close enough to 2024? Because I don't know if 2024 is in the range, but where do I go to? Now, this is where we talk about how Fn actually works. Now, Fn is counting the number of zeros. We have mentioned how the logic works. In general, it's the number of multiples of 5 is floor n over 5. And then n over 25, n over 125, and n over 625, and so on. This is the meaning of Fn. I can estimate this using a geometric series. Now this is an estimation for what purpose? We're going to see in a while. This is going to be approximately n over 4. Now, even if you're like, okay, how do you calculate that? No, it's an estimate, so relax. You do not need to be so exact. There are lots of things you're like, isn't this I'm supposed to round down? So this estimate is going to be too big. Yes, I also know. The whole point is we don't need to be very exact. I just want to know where to look. And if I want to know where to look, you are telling me that this is n over 4 roughly, so it will hit 2024 at around 4 times of that. So my first go-to is f of 8100. That's around 4 times of that. And that will be this over 5, that over 5 again, and then that over 5. You keep rounding down each time. You will be happy to find out that we are not far away at all. In fact, we are at 2022, and if we're at 2022, it means that 8105 gives you the next one, and 8110 gives you the next one. So that is where our journey ends. That's also where our problem essentially ends, because once we have this, we just count the number of rows in here. 8110 over 5. Each row has 5 things. So 5 to 8110 has got 1622 numbers. And 1622 numbers appear here. That's the range. That's the meaning of range. So your answer is 1622. Except that the question asks you for not in the range. So make sure that you are reading carefully. It's 2024 minus that. Okay, I want to take this as well as some of the later questions will reinforce this point. I'll take this time to say, if you did not even know how to count the number of zeros before this question was explained, please take that away. But if you did not know how to count the number of zeros, you would have no chance of solving this question, because you are doing so-called higher level logic on top of knowing how to count number of zeros. Now, this is how some of the last few questions are like. They build on past classic SMO ideas. Therefore, if you look at something where you have truly no idea, skip it first. I'll keep saying this as a practical consideration. Skip it first if you've never seen something like it at all, because you're not going to be able to work out that many things in that little time. It's probably not worth it. Okay. Question 19. On a deserted island, the residents speak the language, and this language uses only 21 letters and 3 letters of each, and they only seem to worry about the 3 letters without worrying about order. Don't worry about the logic of this. The highlight of this question is that you're just picking 3 letters without worrying about spelling. That's great, right? So it, and T are the same word because they have a E, and a T. So this would be a really nice language. Imagine if this were true of, let's say, Chinese, right? You just have the 笔画, right? If the order did not matter, Chinese would be very easy. No, Chinese would not be very easy if the 笔画 order doesn't matter, because no one could read anything anymore. Anyway, all their words contain exactly 3 letters, not necessarily distinct. I can split into cases just of 3 distinct, repeated, and then just 3 repeated that are all the same. This should be quite easy to count, because 21 choose 3 comes here. 2 repeated plus 1 is 21 choices times 20 choices. Remember, no ordering. And then 3 repeated is just 21. So once again, your main challenge is to make sure that you do not calculate this thing wrongly. This is 1330, this is 420, this is 21, and it adds to 1771. Funny story is that I actually miscounted when I was setting this question. I wanted the answer to be 2024, and if this were 22, the answer would have been 2024. But I put the wrong number in, so I guess you did not get the pleasure of seeing a 2024 answer mysteriously show up. But that does happen in the SMO, right? The 2024 does show up in unusual places. If you did the same thing for 22, it would actually give you 2024. And some of you may be able to figure out why I messed up, but I messed up in a way that is fairly harmless, unlike the question 15, where technically the question has now got 2 answers. This one's just, the answer becomes not that exciting. Question 20. Determine the largest positive integer m such that this is greater than or equals to m for all real numbers x. There are 2 ways that you can do this, and I will first mention the high-powered way because this will only be relevant to like a small handful of people. So for the small handful of you who are familiar with Cauchy-Schwarz, you can immediately get this from Cauchy-Schwarz. And so if you knew Cauchy-Schwarz, the idea of Cauchy-Schwarz is to plonk in appropriate things so that the geometric means are nice. And this would be an example of that. This is 120 over 11, and so that means that m you would round down and get 10. Now this is my 1-minute explanation for those of you who know Cauchy-Schwarz. If you do not know Cauchy-Schwarz, my alternative explanation is that I would just let y be sine squared x. And 1 minus y is cosine squared x, and this is just completing the square. So many of the SMO questions are like this. You're going to read the solution and say, wait, I don't know what's Cauchy-Schwarz. And then you get a bit stressed about trying to actually understand what is Cauchy-Schwarz. It turns out that you don't really need to worry too much about some of those theorems. You will end up with the same thing, 120 over 11, if you do the completing the square carefully enough. So same thing that gives you the same answer. Even powers of sine and cosine. Take note of these. When everything are even powers, you can do a substitution like this that will completely remove trigo from the picture. And for those of you who are less experienced with trigonometry, music to your ears. Remove trigonometry from the picture. But this is ideal if your powers are even and the angles are the same throughout the problem. I should say that equality can hold. Y can be certainly 6 over 11 when sine squared x is 6 over 11, which is possible since that's between 0 and 1. So no problems here. If you're doing Cauchy-Schwarz, you would technically need to check that the equality case is valid, which I will leave for those of you who prefer that. I'll leave you to check that it is also very much valid. 21. Almost symmetric series of equations, but not exactly. I am just going to present a method with the knowledge that there are actually a lot of possible methods for something like this. So whatever I'm suggesting, please do not think it's the only way to solve the question. But whatever I'm suggesting here is going to be the correct spirit to adopt when solving such questions, which is to try to make use of symmetry as much as you can. Now what I'm going to do is to divide by the yz, xy and xz, because alpha appears on the right hand side. So I'll divide it over. Let's say for the first one, you end up with x over y plus y over z equals to 3 alpha. And likewise, if you were to do something similar for the other two, you're going to end up with z over x plus x over y is 4 alpha. And the last one, you're going to divide by xz and get y over z plus z over x equals to 5 alpha. Notice that these are the same 3 things that are repeating themselves, and this is great news because it means I can solve for them. Just add the things together. And divide by 2 to get 6 alpha, and then subtract off in order to find that z over x is 3 alpha, x over y is alpha, and y over z is 2 alpha. At this point, you realize that you can just multiply these together, and that's the other thing that we often do. So when you have got symmetric looking equations, we add them all together, multiply them all together, or divide the whole thing, multiply the whole thing. A lot of it is the whole thing. Do not just substitute here and there and make it look more and more and more messy. Make use of the niceness of the equations. So 6 alpha cubed equals to 1, and your answer is that 300 alpha cubed is 15. Take note, the question asks you for 300 alpha cubed as well. You should not be able to actually find x, y, and z, because based on what we discovered here, you could scale them all up or down by a particular factor, and yet that would still be the same statements being satisfied. So you can't find x, y, z, but you can find alpha. 22 is a trick question. Quite a number of you got tricked. You got tricked because of the fact that either you didn't read carefully, or you didn't fully appreciate the implications of a real number x, not an integer x, but a real number x. You may not have fully appreciated the implications of a real number x. The implications of a real number x is that this interval is of length 20, 23. So it's kind of like if I pick a real number from the interval the real number from the interval 1 to 3, the length is 2. And so your length is not 3 because it's 3 possibilities, it's 2 because of the literal distance. So when you're marking out your intervals on the number line, it's over 2023. Now that's the one trick that's involved. Other than that, classic absolute value question, just split the number line into different regions. The critical points of your number line are when all of those individual ones are 0, so there's a 20, 202, and 2024, not to scale. And the different intervals are what you check. So these are 4 intervals. You don't have to check the right side because it stops at 2024. Now, if x is less than or equals to 2, well, between 1 and 2, open up everything. And you realize that, well, the left hand side, this is just going to be bigger because the x cancels off and the constants are bigger. Next, you try from 2 to 20. So at this point, this is included. From 2 to 20, now this will flip. And it is still pretty obvious that the left side is now 2022, which is much bigger than the right hand side. So this will also be included. Continue on to 202, beg your pardon. And this is just still true, right? The left hand side is 2022, the right hand side is 182. So this part will still continue to work. And if you go up to 2024, finally you have something where it doesn't always work. So this is still 2024 minus x. Everything else becomes in the correct direction. If you solve this, finally you have something to do. You end up with x is less than or equals to 1122. And if x is less than or equals to 1122, then it means that everything up to 1122 actually works. That is an interval, not to scale, from 1 to 1122 out of 1 to 2024. So your answer or rather your probability, is 1121 over 2023, which is where it got a little bit sneaky because of the real number condition. I know there aren't many probability questions in the SMO Senior, but probability is in your many of your schools' Sec 4 syllabus, not in a very complicated way, but anything that appears in your syllabus can appear in the SMO Senior. Anything that doesn't appear in your syllabus can also appear in the SMO, but certainly probability is very much something that is in play. 23. In the diagram below, CA is a diameter, DB is a chord, they are extended to meet at P. Perpendiculars from A and C to line BD are E and F respectively. This here is 20 and this here is 150, and we want to find what is DF. The first thing that I want to say about something like this is that you should not assume the diagram is to scale. However, in this diagram, the only thing that can possibly be part of scale is 20 and 150, right? The diameter is really a diameter, the circle is really a circle, the chord is really a chord, the right angle is really a right angle, right? All of those things are true. From a guessing perspective, I think some of you realize that these two kind of look the same. If you don't know better, guess that they are the same. Because if EB equals to DF is true, that may not depend on scale. I can tell you here that that's actually true, that's why I'm saying this, but it doesn't rely on scale of the numbers 20 and 150. It just relies on everything else being true. Now, how we will actually do this turns out to be very simple. Just start from the point O and draw the, I want to say bisector, and I'm deliberately being vague about bisecting what? So you drop the perpendicular from O to BD. On one hand, it means that B, okay, I'll call this M. So BM and MD are the same because you are in a circle. So you can say congruent triangles. For example, these BOM and DOM are congruent. On the other hand, we also know that these are equal. And so if you were to just draw in another line down here, which funnily enough, you will hit that, right? This angle in a semicircle is 90 degrees. If you were to draw another line here, it would tell you that clearly these two are equal, and so in fact it also bisects this. So EM simultaneously is equal to MF, and the implication is that BE equals to DF, and they are both 20. Note the redundant information, right? 150 is redundant. P is also redundant. It is one of these things where in the SMO, if you look at recent years questions, some of them do have redundant information to kind of guess proof it a little bit. If I just put EB is 20 and nothing else, everyone will guess 20. So I try to make it a bit less obvious to guess. But you still can guess if, let's say, you don't know. Having said that, this question is not especially hard because we don't use any heavy circle properties. On the other hand, question 24 is a bit more tricky. It's another question that is to do with, well, lots of equal things. In fact, it's a regular polygon ABCDE. I didn't write in the angles in the diagram, I just only marked out where they are, because otherwise it's a bit hard to see. This one's 59 degrees, this is 144 degrees, and this is the one that we want to know. Now, I like to think of a lot of these questions in terms of if I had to draw it myself. You see, of course, the diagram being there is good, right? But it deprives you of the opportunity to think about actually drawing it yourself. So I like to draw the diagram myself. If let's say that I just drew a regular pentagon, I'm not going to worry about it being in the same so-called direction. if I drew the regular pentagon myself, I want to put f such that EBF is 59 degrees. Now EBF is 59 degrees can essentially be said that it's just f is on this line, right, where this is the 59 degree angle. Draw f somewhere on this line. AFB is 144 degrees. Now where does that actually place me? Some of you have learned loci and construction in various places. That's the philosophy I want to take. AFB is 144 degrees. What is the set of points f such that AFB is 144 degrees? Now, I don't know, but let's say that if I drew some random example, which would be, well, if I drew it to be kind of like symmetric, right? This is one possible place where I could put f, where it's 144 degrees. Now, if I put another plausible location of f that is 144 degrees, you realize that actually the two locations of f are now going to be concyclic with a and b. In other words, any points that I put, AFB is 144 degrees, is actually an arc. It is telling me somewhere along, okay, I'll just clear all this, somewhere along this arc, where this arc is the arc where AB has 144 degrees in its minor segment. Remember what I was saying about chords and segments in the section 2 of our review for, what was the question number again? For question 16. I mentioned about, think of it as a chord corresponding to an angle. So this AB chord is a 144 degree angle in terms of the minor segment, but more likely we would care about AB would be 36 degrees in a minor segment, so in a major segment. And this is actually very suspicious if you realize that we are working with pentagons, because the angle at the center becomes 72 degrees, which is exactly what happens if you were to draw the center of the pentagon. So the center of the pentagon being 72 degrees, this would be 288 degrees, is consistent with this being 144 degrees. In other words, it just lies on the circumcircle of the regular pentagon. That's what has happened here. Now I'm saying this in a very elaborate way because that's how I would arrive at this motivation, but I mean the reasoning itself is just here. Suppose it goes through A, B, C, D, E. Now this will be 288 degrees. That's twice of 144 degrees, so F also lies on the circle. Easy explanation, not easy to see that that is the significance. So not easy to notice, but easy to justify, and also quite easy to use because now BDF is just going to be equal to BAF by your angles in the same segment. This is 144 degrees, and your angle ABF, well, angle ABE is going to be 36 degrees, and so angle ABF is 23 degrees, and angle A would be 180 minus 144 minus 23. So 13 degrees would be the correct answer. I realize that this is actually not such a long review. This is not so long because of a very simple fact that for the SMO questions behind, many of them are hard to think of, but not actually that long in terms of their actual solution. And the final question is the perfect example of that. It looks scary, and it is legitimately not easy. I can easily imagine that something like this, just change it to a general case, could be a SMO Senior round 2 question as well, where you would need to go through a lot of details, but weirdly enough, it may be easier. It may be easier to do it in the SMO round 2 situation when they give you the general case, because, hey, that's M. It cannot be that important that it's 2024. It should be something that actually comes from a more general situation, so it's time to play. Take the question, and since 2024 is way too big, there's too many factors to do something like this, just try to write it down. Small case, for example, how will this look like? And when you do this, please do not actually do this with the, not 3, 5. Do not do this with only the intention of finding a pattern in the answer. Do this with the intention of finding a pattern in the logic. We know the story of the apple falling on Newton's head, right? Newton was not intrigued by the fact that the apple landed on his head. He was intrigued by the fact, oh, gravity, it comes down. Now, you are not so interested in the end result, which is a bump on your head. The process matters. And here, the sum of the squares of the positive integers not exceeding n that are relatively prime to n is one of the most specific but weird things you have probably ever heard in terms of a function. Make use of that. So what is s of 1? It's 1 squared. What is s of 2? Now, relatively prime to 2 is just 1 again. Now, what's relatively prime to 5? 1, 2, 3, 4 are all relatively prime to 5. What's relatively prime to 10? 1, 3, 7, and 9. Now take this, and you can calculate it by all means, and it's small enough that you should certainly give that a try. But I'm going to sort of just spoiler by saying that put this all together into a common denominator of 10 squared and see what happens. Now, it can be a common denominator for sure, right? Because of the fact that all of these things here are factors of 10 and later of 2024. So this would be something I can do in general. This one's all multiplied by 2. And then this one's do not multiply anything. And do you realize what has happened here? This is just 1 squared to 10 squared in a permutation that was based on the order that I wrote stuff in. But it's a permutation of all the squares. Now in retrospect, then this becomes like, actually, yeah, of course it will be there, because if you think of it in the reverse direction, let's say that I've got 6 squared over 10 squared, I would know that it's 3 squared over 5 squared, I can find it in here. If I, let's say, got 5 squared over 10 squared, this is going to be 1 squared over 2 squared, I can find it down here. So I'm not shocked that all of these are going to appear exactly once each. Just reduce it to lowest terms and it will show up. So this is great. This is great because I know that the exact same argument will work for 2024. Why not? So I don't need to calculate this. That's not important. More important is that I see no reason why this would fail. And the sum of squares from 1 to 2024 requires us to know the sum of squares identity. We've been talking in this series of videos quite a bit about ways to add up a lot of things. This is the famous formula one. If you don't know, now you know. Right? Either group things together, pair things up, make things cancel. Now this is famous formula. So 2024 squared is going to be equal to this thing here, and before you worry that this is too messy, just realize that I could actually simplify it in terms of n first. So this is 2n squared plus 3n plus 1 over 6n, which would simplify to n over 3 plus half plus 1 over 6n. Now just put in 2024 into this. Well, this is just tiny, so I don't care about what it's equal to exactly. This is 672 and 2/3, so 74 and 2/3 plus 1/2 plus something tiny is 675 and 1/6 plus something tiny, and so 675 is the numerical answer. And that's where I'm going to conclude for now. This is not an easy mock paper, but this is a mock paper that I have tried to design in order to be able to say as many of the things I've said as possible, both in terms of concrete methods as well as just meta SMO suggestions. As always, please feel free to share your opinions. Please feel free to share if I've said anything wrong, or if you think that there are better ways to approach some of these questions. Remember that what is the best way for a question is the way that allows you to solve a question. So what's best for me may not be the best for you. What I am suggesting here is only what I think is A, not too long, and B, I can explain how I can think of it. But if you can think of something else in a different way, do that. And if you think you will never think of this ever, skip the question. The SMO Senior is hard enough that you can afford to skip some of the questions that you don't like and just pick the questions that you have a bit more confidence in. So that's all I have to say for now. All the best to anyone that's taking the SMO in a couple of days, and see you soon for the review session on the day or day after the SMO round 1.